Hello everyone, this is Cavell, and today I will be talking about solving systems of linear equations with two variables, and we'll be using the method of elimination. So, our first problem given to us is these two equations. We have 6x minus 5y is equal to 8, negative 12x plus 2y is equal to 0. So when it comes to using the method of elimination, our goal is to look at the coefficients of these equations and see if any of these coefficients are a multiple of the other equation, meaning we want to see if we can multiply one of these equations by a certain number so that they can cancel out with the same variable's coefficient. So for example, if we look at these two equations, I see 6x minus 5y is equal to 8, negative 12x plus 2y is equal to 0. I can see that if I multiply the first equation by 2, I would get 12x, and that would cancel out with a negative 12x in the bottom. So let's do exactly that. So we'll have 2 times 6x minus 5y is equal to 8. Remember, we're multiplying this all by 2. And we can do that because as long as these two sides are still equal, we can do anything to these sides as long as it's the same thing to each side. So then we get 12x minus 10y is equal to 16, right? So this equation still just comes along for the ride. Negative 12x plus 2y is equal to 0. As you can see here, the 12x and the negative 12x would cancel out when we add them. So those would cancel out. Negative 10y plus 2y is negative 8y. Is equal to 16. Divide by negative 8. Divide by negative 8. We get y equals to negative 2. Alright, so far so good. So now that we have y equals negative 2, we can simply find out what x is by simply plugging in y equals negative 2 and solving for x. So if y is equal to negative 2, we'll get 6x minus 5 times negative 2 is equal to 8. We'll then get 6x minus 5 times negative 2, which is just plus 10. Oh, plus 10 is equal to 8. We subtract by 10 on each side. We get 6x is equal to negative 2. Divide by 6. Divide by 6, right? Then we are left with x is equal to negative 2 over 6. Or if we simplify, we get x is equal to negative 1/3. So far so good. So using method of elimination, we are left with x is equal to 1/3, y is equal to negative 2. So we're not done, right? When it comes to math, it's always important to check your work. So let's do exactly that. Let's plug in these values into the equations and see if they actually equal to each other. So let's do that. So 6 times negative 1/3 minus 5 times negative 2 should equal to 8. 6 times negative 1/3 is negative 2 minus 5 times negative 2, which is plus 10. Is equal to 8. Negative 2 plus 10 is 8. 8. Right, this is equal to each other, so the first equation is fine. So far so good. Now let's do the second equation. We have negative 12x. X is negative 1/3 plus 2 times negative 2 should equal to 0. Let's check. Negative 12 times negative 1/3 is just a positive number, but 12 divided by 3 is 4. Plus, what's 2 times negative 2? That's negative 4, right? Is this equal to 0? Yes, it is. 4 minus 4 is equal to 0. 0 is equal to 0. That means we did our problem correctly by checking, or by method of elimination. So just to review, we looked at the first equation and we saw that we can easily multiply this by 2 to cancel out the negative 12x with the 12x, and then from there on out we got the equations to be only one variable equaling to some constant, and we just solve for that variable. Right, so far so good. So our next question is negative 2x plus 10y equals to 2. 5x minus 5y, or sorry, 25y is equal to 3. This is the equations we are given. Once again, if we look at these equations, we want to see what variable, or sorry, what number we can multiply these equations so that it can cancel out with the other variables. And we can see that there's no easy answer to this. There isn't an easy multiple that we can do. So in that case, I'll just stick with y. I want to get rid of the y's. So 10 times what gives me 25, because I want these to add and become 0, right? So that means 10 times 2 and 1/2, sorry, will give me negative 25. So we'll have to multiply by negative 2 and 1/2. So 2x plus 10y is equal to 2. We want to multiply by negative 2 and 1/2, right? Another way of writing this would just be negative 4. Oh, sorry. 5/2, right? Times negative 2x plus 10y is equal to 2, right? Let's distribute this negative 5/2 into this equation, right? So we get negative 5 times negative 2x, which is just positive 10x all over 2. Negative 5 times 10 is minus 50y, right? Over 2. Negative 5 times 2 is negative 10 over 2. And then as we can see, we can simplify this to 5x minus 25y is equal to negative 5, right? So now if we take a look at these equations, right, they're essentially the same in the coefficients of the variables, except the constant, right? And now when this happens, that means these lines have the same slope, except they have different y-intercepts, meaning these lines are essentially parallel to each other. They will never touch each other, right? And how do I know this? Because I can see that the rate in which x is increasing is still the same as this, as the top one. Y is decreasing at the same rate as the top one, except they're all equal to different constants. Hence, I know right off the bat these two equations are actually parallel, and there will be no solution. Right. So whenever you have an equation of this form, 5x minus 25y is equal to a constant, right? This is called, I believe it is called, I want to say it's 2-point form equation of a line, but let me just double check here. So yes, sorry, it is not 2 point. It is called standard form. So standard form is in the shape of ax plus by is equal to c. Alright, this is called standard form. Just to refresh, slope intercept is what we're all familiar with. Y equals mx plus b, where m equals slope and b equals intercept, or sorry, y intercept. And lastly, we have point slope, which is y minus y1 is equal to n times x minus x1. Essentially, m is slope, just like the slope intercept form, and x1, y1 are just lines. Sorry, not lines. They're a point on the line. So, yep, that's it for today. This is solving systems of linear equations using elimination. All right, thank you for watching, and I'll see you later. Bye bye.